Today we're going to look at using elimination when you have to multiply both equations in order to get a variable to have the same coefficient in order for you to add or subtract to eliminate that variable. So if we take a look at the two systems of the system of equations that we have listed here, 2y plus 5x equals 3 and 3y plus 7x equals 1, we'll notice that none of the variables have any coefficients that are the same. We'll also notice that if we look at the 3 and the 2, there's nothing we can easily multiply 2 by to make it a 3, and there's nothing we can easily multiply 3 by to make it a 2. In addition, there's nothing we can do to the 5 to easily make it into a 7. There's nothing we can do to the 7 to easily make it into the 5. So what we're going to have to do here is use a technique where we multiply the top equation and the bottom equation by something in order to make the coefficients the same. Very similar to the way you kind of find common denominators. Now, in terms of using the x or the y, it's entirely up to you which one you pick. I'm going to pick the y because it's lower values. You can pick the x if you want at another time. So let's figure out what we can multiply by. In the first equation, we can multiply that top by 3. And in the other equation, we can multiply it by 2. And by doing that, that'll make the y variable have a coefficient of 6. Now, one more thing here. We really want to make sure that we multiply one of these two by a negative if we want to be able to add the equations. And if we just want to subtract the equations, then we don't worry about that. I'm going to try subtracting. So when we do that multiplication, the top equation becomes 6y plus 15x plus 9. The bottom equation becomes 6y plus 14x plus 2. And we'll notice that the top equation and the bottom equation both now have a 6 in common. So when we subtract these two, the y term will eliminate. When we subtract these two equations, we get 6y minus 6y, which is 0, 15x minus 14x, which is just x, and 9 minus 2, which is 7. So x equals 7. And again, we're now going to go back and plug into one of the two original equations, remembering to make sure you plug into the original, not to the values after you've multiplied it. So we want to go way up here to the original equation. So when we complete our algebra, we find out that y is equal to negative 16. So we now know that x is 7 and y equals negative 16. So our intersection point is negative 7, positive 7, negative 16. Please pause the video and copy this into your notes. Okay, now it's your turn. Solve the following system of equations using elimination. However, I want you to make sure that you use the y variable that you eliminate. So that way we're eliminating the same thing when we check the solution. So again, eliminate the y variable. Please pause the video and work on the problem. Here's the solution. What we decided to do is multiply the top equation by 5 and the bottom equation by 3 in order to make the y coefficients both 15. Then by subtracting both equations, we got 29x equals 16. Solving for x, we got 16 over 29. And again, you could use this as a decimal. Then we substituted the 16 over 29 back into one of the two original equations. I chose the 2x plus 5y equals 3. By doing the algebra there, I found out that y was equal to 11 over 29. Therefore, our intersection point is 16 over 29, comma, 11 over 29. Please pause the video, copy this into your notes. Here's another problem. Again, eliminate the variable y from the system of equations. Also take note that there's a negative sign here. So we can probably just add the two equations once we've made the coefficients the same value. Please pause the video and work out the solution. Here's the solution. Please pause the video and copy this into your notes.